Welcome to an example in which we are looking at a hypothesis test. It says, suppose that for more than 10 years, doctors have been using a treatment for skin cancer that has a 72% cure rate. Suppose further that a new treatment for skin cancer was developed and 60 patients received the new treatment, with 49 of them being cured. Is the percent cure rate higher for the new treatment? What can be concluded at the alpha 0.05 level of significance? Okay, so basically, we're wondering if the new treatment's better than the old, right? The old treatment has a 72% cure rate. The new treatment, they gave it to 60 patients and 49 of them were cured. Is that better than the old? Well, if you just take 49 divided by 60 on your calculator, let me see. I don't know what that is. I don't know. Here, I got my calculator. I'm going to go. Well, here, 49 over 60. I'll go to the calculator that's on the, here we go, scientific calculator. 49 divided by 60. Looks like it's 81%. See it over there? 81%. I'll bring it over for us. So I just kind of, I don't know if we really need this, but here we go. So there we go. So I just did the little calculator. 49 over 60 came out to be 81, like closer to 82%, actually, huh? 82%. So that's about 82%. It's about, let's say about 82%. So that means that the so 49 out of 60. So it says 49 of them were cured, 60 patients received the new treatment, 49 of them being cured. 49, so that's 82%. The old treatment, here's the old, right? This is the old treatment, and this is the new. So is the new one better? Well, yeah, it looks like it's about 10% better, right? From 72% to 82%. That's going up, certainly. So what's their question? Is the percent cure rate higher? Well, of course it's higher. Well, what they really mean is there strong evidence. Is there strong evidence? Because the problem is we only gave it to 60 patients, right? Maybe those were just a lucky 60 patients, or a lot of them were anyway, 49 of them were. And so really maybe the new treatment's not better. Maybe it's a little worse even, but that we happen to get a lucky 60 patients where a lot of them were just pretty healthy. They were going to be cured anyway, and it wasn't the new treatment. And we'll find out the truth in 10 years after we've done the new treatment a whole bunch, and we might find out, well, it's actually only a 62% cure rate. And we just got a lucky group of 60 the first time when we tested it out, making us think the new treatment was better when really it wasn't. That can happen, right? That'd be a big mistake. So how do we know? The question is, what's the chances of that? And so if the chances of that being just a lucky sample are really low, then we're going to say there's strong evidence that the new treatment is better. But if the chances of maybe getting a lucky group of 60, because maybe that's not enough people, we need a bigger sample. Maybe if there's a pretty good chance of getting a lucky group of 60, then we're going to say, well, that's not strong evidence. So we're not really sure yet that the new treatment's better. That's what this is all about. How do we test this and figure this out? Okay, so first off, when you choose what kind of study to do, there's two options. There's a z-test and a t-test. The z-test is for a population proportion, and that's certainly what we're doing here. We're all about a percentage, right? It all started off with the old treatment is 72%. So we're all about percentage here. So choose that one, not mean. The other option is t-test for mean. There's nothing in here about average, mean. Mean means average. There's no averages anywhere here. It's all about percent right there. And there's the word percent again. So it's percent or proportion. That's the one you want to choose. Now down here, HO, and this will be H1. Now HO, there's two options. What you choose, it's P or U. So we're going to definitely choose the P option because we're doing, again, percent. The U, the mu, it's actually a mu, that's for average. That's when you're doing an average or mean problem. We're not doing that right now. There's this average, and it's going to be equals. It's always equal. So you look in the notes, you'll see that the HO is always equal. And then down here, the H1 will be greater, less, or not equal, depending on the words of the problem. Now, what do the words of the problem say? Well, they say right here, is the percent cure rate higher? Higher means greater, huh? Higher. So we choose the greater option. Now, if it said lower, we would choose the less. If it said different, then you would choose the not equal, because the two things are different, they're not equal, right? Equal means same, not equal means different. So based on what, so you look for the keyword higher, bigger, faster, taller, all those mean greater. It's bigger, faster, taller, higher. And if they say, you know, smaller or shorter or less, those are all less, aren't they? Fewer, something like that, some word like that. Those are all less. And then if they say same or different or something like that, that means not equal, because not equal is not the same, not equal. So ours says higher, higher, higher than what? Higher than the old treatment. What was the old? 72. See how I came up with that number right there? 72% was the old treatment. So they're saying, is the new treatment higher than the old? That's the old, 72. And now whatever number goes here, these two are always the same. So this is going to be 0.72 also. So that sets up our, these are like two attorneys in a court of law arguing. One attorney is saying, hey, the percentage for the new treatment is equal. It's the same as the old one, 0.72. It's the same percentage of cure as the old one. And the other attorney says, no. The percentage for the new treatment is greater than the old, greater than 0.72. The new one's better, which that seems to be what we found out, 82%. But that might have just been lucky sample. That's what we're going to see. Is there evidence to support the new or not? Well, how do we figure that out? Well, we go to the calculator. The net down here now, test statistic and the one after that p-value, those are found from the calculator. Now, where are we going to go on the calculator? Let me write it for you here. Calculator online. The online calculator, where's that? So if you click on the home page, you click the calculator icon, you'll open up, and here is the calculator. Enter that is online. When you click on the calculator icon, you get the online calculator. Where are we going to go? Well, notice there's a few hypotheses. Hypothesis test for mean, with statistics, with data, and proportion. We're going to choose number 16. Hypothesis test for proportion, because we're talking about a proportion, a percentage. We're not talking about a mean. Mean is average. There's no mean in this one. So we're going to choose, what number is that? Number 16. So the calculator is number 16. Hypothesis test for proportion, which is P, percentage. So that's what you're going to choose. And when you do that, let me show you what it'll look like. So, what are our numbers? We're going to put in 49 out of, let me just bump that mistakenly. Here we go. We're going to choose 49 out of 60, as you see right here, 49 out of 60 and 72%. So let's go back to it. So here's the calculator. Hypothesis test for proportion. And so I'm going to put in 49 out of 60, in is 60, 49 of them. And the P0 is 0.72. And over here was greater. I'm going to choose, see the different options? I'm going to choose greater. And I'm going to hit calculate. And there we go. I'll bring that over and write on it so you can understand it better. Let me bring it in here for us. Show it. Okay, so here's what we just did. So the N, that's the total number of people, and there were 60 people in the study, right? Out of 60 people, and 49 of them, that's your X and that's your N. So online calculator, N is 60, X is 49. 49 people were cured out of 60 total. The P0 is 0.72. Notice I put in point, it's 0.7. See that little decimal point there? P0 equals 0. Put a 0 in front just for clarity. 0.72. Now, what's that? What is that P0? Well, the P0, the little zero, let that remind you. When you see that little P0, go back and grab the number next to H0. Number next to H0. Let that little zero remind you. Oh, go back and get the number next to H0. So I did that. I went back and got the number next to H0, the 0.72. That goes in P0. Okay, and then what else is there on that calculator? Oh, and then over here, choose greater. Choose greater because we had greater because they were asking us H1. Choose the greater option. Choose that bubble. And then hit the buttons, and you'll get this Z is 1.668, and the p-value there. Let's see if we get that. Z is 1.668. That's right. He's rounded. You can just copy this whole thing and paste it in. You don't need to round it. And the p-value is 0.04769. Again, you can just copy and paste that in or round it, 0.0477, I guess. Yeah, 0.0477. There we go. Okay, now put those values in there. Now, what are we going to do next? Next, this part down here, whoops. It talks about comparing p-values. So I'm going to put a p-value, and alpha level. Let me show you that. So the p-value is right here. P-value. So bring that over. 0.0477. And then the alpha level. Where's the alpha level? Right up here. See, it says what it asks, what can be concluded at the alpha 0.05 level of significance? What can be concluded? Okay, at the alpha 0.05 level. So alpha is 0.05. So 0.05. Now, the question is, which of those is bigger or smaller? Well, this is lower, isn't it? 0.047 is lower than 0.05. So that's lower. So that p-value is lower. Okay. And so that's where we choose the lower here. Now, what does that mean about our conclusion? What does that mean about anything? Well, if you come back up here to the notes, let me show you the notes right up here. So here's the notes from class. And that's all about, there's two options. There's option number 1 and there's option number 2. Option number 1 says if p is less than alpha, do all this stuff. Option 2 says if p is greater than alpha, then do all that stuff. What was ours again? Coming on back. Our p-value is less. P-value is lower. 0.04 is lower than 0.05. So what does that mean? If the p-value is, so we're this one here, aren't we? P-value is less than alpha. What does that mean? When the p is low, right, it's less, it's low, the null must go. The null is the HM. This means when the p-value is low, less than alpha, the null H0 must go away. That is, reject the HO, keep H1, strong evidence. See those words? I'm going to bring them all back. Reject HO, keep H1, strong evidence. So bring that back. It's really important stuff. So reject HO, keep H1, strong evidence. So that means reject HO, which we put right there. Reject the null. HO means, again, the null. Null is a fancy math word for zero. Maybe you've heard like the check is null and void. Null means zero. So HO is the null. So reject HO, reject the null, reject them. So we say reject the null. And this is thus the evidence is strong. Right here, strong evidence. And then finally, down here. So our conclusion is that for the new skin cancer, the percentage cured is what? Well, the answer is going to be greater than 72%. How do we know that? Well, it's all about what we kept in the end. What did we keep? We keep H1. And what does H1 say? So remember, this was all about these two attorneys, HO and H1. What they were arguing with each other, presenting evidence for their cases. HO was saying the percentage of the new treatment is equal to 0.72, and H1 was saying, no, percentage for the new treatment is greater than the old one, greater than 0.72. Which one did we believe in the end? Which one had the evidence right here? Keep H1. So we believe this guy, not the other one. H1, which says P is greater than 0.72, greater than. The percentage cured for the new treatment, the percentage, the P, is greater than 72%. P is greater than 0.72. That's what we believe in the end. That's where the evidence is. Even though it's only 60 people, it turns out it's enough to provide strong evidence. What's strong evidence? Well, the p-value is 0.047, which means the p-value, P stands for probability. The p-value is the probability that the results were just lucky, that we just got a lucky 60 people. There's always a chance of that. What was the chance? It was only a 4% chance, which was lower than 5. The alpha level is how low they wanted the chance of luck. They were saying, look, we want these results to be less than a 5% chance of luck. And we said, well, we got a 4%, 4.7% chance of luck, which is lower. So that's a low chance of luck. We think of that as strong evidence that the new treatment really is greater. The cure rate is really greater than the old treatment. So there we go. That's our conclusion to the matter.